Good day, my wonderful celebrity nation. Today we are working on lecture 5 of our Physics 102, topic Coulombs Law. It is still your favorite teacher, Dr. UD Jesus. Fasten your seatbelt. Let's know how we can achieve this in a very easy way we can. First, let's look at the lecture objectives. At the end of this lecture, you as a student should be able to state Coulombs law and apply it. You should be able to discuss intensively electrostatic force and explaining everything about it. And I expect you to calculate charges, forces, distance using Coulombs law. Get ready. Let's do this. But before then, let's look at the revision of our last lecture. In our last lecture, we treated methods of charging a body. And you remember we said that there are 3 primary methods of charging a body. Number 1 is the method of friction. In method of friction, 2 insulating bodies come together, rubbing themselves, and both will get charged in opposite form. What does that mean? These 2 neutral bodies rubbing together, one will become positively charged and the other one will become negatively charged. And this is as a result of one of the bodies rubbing off electron from the other body, whereby the one that rubbed off electron becomes negatively charged, while the one that electron is being rubbed off from becomes positively charged. While the second one is charging by conduction. In this particular process, a charged body is being placed on a neutral body to get the neutral body charged. So another name for charging by conduction is charging by contact. And in charging by conduction, the 2 bodies, both the one charging and the one that is to be charged, maintain the same charge after the process. For example, if I use an iron rod to charge a sphere, at the end of it all, by the process of conduction, both the iron rod and the sphere maintain the same charge. If the rod I'm using that is charged is negatively charged, that means whatever I am charging that rod or whatever I'm charging with the rod will still maintain the negative charge. Then the other last one there is charging by induction. Charging by induction, you bring a charged body and a neutral body close, but without contact. And what happens? The charged body will induce charge in the neutral body by the process called polarization. That's redistribution of charges. And when this happens, at any point of earthing, that body becomes charged. So now in induction, unlike conduction, the body that is charged maintains an opposite charge to the body that is charging it. This is more like a summary of our last class. So today, let's go into the class we have today. Today, we are discussing Coulombs Law. And most of you have been hearing about Coulombs Law. But let's have a detailed meaning of what Coulombs Law is. It's a law in physics that commands or controls the character of charge. Now let's state Coulombs Law. Coulombs Law states that the force between 2 point charges, is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. I repeat, Coulombs law states that the force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Let me explain. If you see the two balls down, we have Q1, we have Q2. Those are two different charges, the charge 1 and the charge 2. Now, Coulomb's law says that whenever you have a system like this where we have two isolated charges acting on each other, that they interact with a force, and that force of interaction is directly proportional to the product of both of them. That is Q1 times Q2 put together is directly proportional to the force of interaction. And that the force is inversely proportional to the distance between them, the square of the distance between them. That means the R there is the distance between them. The square of R is inversely proportional to the force. So you now come to the equation where we'll say that the force is equal to KE Q1 Q2 all over R squared. What do we mean by that? If we go by that, you see that force is directly proportional to Q1 Q2, and the same force is inversely proportional to R squared. But you know that proportionality is a dummy sign. So for us to bring in equality, a constant must come in. So we introduce that equality sign and introduce a constant known as Coulomb's constant. Now take that equation down and know it now, because in this 102, you will be dealing with this equation for most of your calculations. F equal to KQ1 Q2 all over R squared. You can repeat it after me. F equal to KQ1 Q2 all over R squared. Now, this is what Coulomb states. They may ask you in your examination, state Coulomb's law. Don't hesitate to tell them that Coulomb's law states that the force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Go further to place the equation. Thank you. Let's move to the next stage. The next thing we want to discuss in Coulomb's law is electrostatic force. And in the mind of any good student now, what will be ringing there is, what is electrostatic force? Because you can't start working on what you do not know. Let's know what electrostatic force is first. Then we can now go ahead to do some calculations about it. Electrostatic force is a force of interaction, either the force of attraction or the force of repulsion between charges. Now, when you keep two charges together, as I said earlier, they interact. Okay, on a more physical thing that you can see, let me leave charges now and concentrate a bit on magnets. When you have two magnets together, they interact. How do they interact? Sometimes you bring two magnets together, North Pole, South Pole. What do you see? They attract each other. They pull your hand together. But now, if you make it North Pole, what do you see? You are forcing it to come together, yet it's pushing your hand apart. The same way in charges. When there are two charges together, for example, positive and negative charge, they interact. And you see them attract each other. But now, if they are like charges, like positive and positive charge, they also interact by repelling each other. So that force of interaction, that force which these charges uses to attract each other or repel each other, is called electrostatic force. hope you're comfortable with that. Now, electrostatic force is a force field. What do we mean by that? There are forces that require contact before you can feel the influence. Example, if I say I'm sliding, that means I'm sliding over something and there is a contact. If I say I pushed him or I pushed something, that means there is force of contact. There was contact before the force can be felt, which is pushing. If I say I dragged him, now I have to make a contact because I can make a physical drag. But now something like okay, if you are in an upstairs and you decide to jump out, do you need something to hold you before you will fall down? No, you will surely fall. And there is a force taking you down, known as gravitational force. But there is no contact between you and the ground floor before you start falling to the ground floor. Exactly the same way, electrostatic force is a force field. It's not a contact force. So it doesn't require contact before you can feel the influence. It doesn't require contact before you can feel the influence. As long as you cross the field, you can feel the influence of electrostatic force. So now we make it known to you that the electrostatic force is the force of interaction between charges. And it is a force field, not a contact force. I know that one is already settling with you. Now, electrostatic force equation. That's exactly what I want us to look at. Electrostatic force equation, as I mentioned earlier in Coulombs Law. Coulombs gave us a law that brought this equation, where he said that the force of interaction between 2-point charges is directly proportional to their product, which is Q1, Q2, and inversely proportional to their distance, to the square of their distance apart, which is r squared. And that equation is given as F equal to KQ1, Q2 all over r squared. I repeat, F equal to KQ1, Q2 all over r squared, where K is the constant of proportionality known as Coulomb's constant. And it has a value 8.987 times 10 raised to the power minus 9. That's the value. But in approximation, most times in calculation, we'll use 9.0 times 10 raised to the power 9. But throughout this lecture, we'll be using this particular number here, 8.987 times 10 raised to the power 9. But I don't know your school. I don't know what your lecturer is teaching with, but whatever they are teaching with, if it's the approximation, which is 9.0, I believe they will still give it to you during the question. It's either they place it after the question and they will say, assuming K equal to this, or they will place it before all the questions, the value of K, but it must be given. It's just like acceleration due to gravity. They will give it to you. They will. So don't panic about that. Now, F is equal to K Q1 Q2 over r squared. The question is, what is K? I told you that K is Coulomb's constant and is given as a value 1 over 4 pi epsilon naught. I said epsilon naught. I didn't say E naught. Epsilon naught. And what is that epsilon naught? Is the permittivity of vacuum. The permittivity of vacuum. The value is also given here, 8.854 times 10 raised to the power minus 12. Then Q1, Q2 all over r squared, those are those quantities that F is directly and inversely proportional to. So K is standing alone as a constant of proportionality. And I said it is called Coulomb's constant. Take this equation down because we will work with it a lot in this particular topic. So try as possible as you can to take it down, not just on your paper, but in your brain. Okay? Now we are heading into practice. We are already in practice where we will now work on this particular thing. The first thing here we are to do is question number 1, which says, what is the magnitude of the electrostatic force of attraction between an alpha particle and an electron placed 10 raised to power 13 meters apart? If you don't understand this question, you might not be able to answer it. I think the first thing here is understanding it. If you understand the question, then you can be able to answer. Now let's go to our solution board and see what we can do there. Now solution to, okay, that's question number 1 there. Let's solve that. Look at it critically. We'll say F equal to K Q1 Q2 all over R squared. This is the formula we have from Coulombs Law. Now from there, we can say that, recall that our K is equal to 8.987 times 10 raised to power 9. This is our K. So that means our Q1 is equal to, what do we have, is the charge of alpha, which is equal to the charge of 2 electrons. That is 2 electron charge. That is equal to 2 times 1.602 times 10 raised to power minus 19. That means Q1 is equal to 3.2 times 10 raised to power minus 19. That is Q1. While my Q2 is given as the charge of electron. And the charge of electron is equal to 1.602 times 10 raised to power minus 19. So looking at it now, we have our R squared. Remember from the formula up there, our R squared will be equal to 10 raised to power minus 13 all squared. This is the same thing as 10 raised to power minus 26. We have acquired that one. Now, if I decide to make a cut from here and use the other side, I can say that F from there is equal to K Q1 Q2 all over R squared. Now that means my F is equal to, I think this is small for the write-up. Let's use the next board of solution. Okay, let's use the next board of solution. Let's continue from where we stopped. We have that F equal to, we have 8.987 times 10 raised to power 9, bracket close, times, then Q1 will be 3.2 times 10 raised to power minus 19, bracket close, Q2 is 1.602 times 10 raised to power minus 19, all closed. Then divided by r squared, which is equal to 10 raised to power minus 26. So from there, so from the equation, we have f equal to, multiplying through, we have 4.607 times 10 times 10 raised to power 20 minus 28. Now everything there divided by 10 raised to power minus 26. This practically will give you 4.607 times 10 raised to power minus 28 divided by 10 raised to power minus 26 is 10 raised to power minus 2. So we have 10 raised to power minus 2. That brings us to the force of interaction to be equal to 4.607 times 10 raised to power minus 2 Newton. And this is our answer. This is the way to go about your calculation in Coulombs Law or electrostatic force. Follow it gradually, follow my voice alongside the calculation and see how it goes. Now, the next thing, let's look at any other way we can help by solving another problem. Problem number 2. Practice problem number 2 says, a small charged conducting sphere is placed near an identical sphere of 4 times 10 raised to the power minus 8 charge, such that the force of repulsion between them is 9 times 10 raised to the power minus 3 Newton. The distance between them is dash. Now, what does this mean? It simply means here that, first, understand the question. They said identical. They didn't mention any other thing. So identical means that they are the same here. So let's solve the problem and see what we have. Now the same thing, don't let them deceive you in any way. Simple. F is equal to, the same way we did the first one. F equal to K, Q1, Q2 all over R squared. First, get your formula. Once you get your formula, then you don't have any reason to panic. You ask yourself here, what is my K? My K is equal to 8.987 times 10 raised to power what? 9. Now, what is my Q1? Q1 was given to you, and it said they are identical. That means Q1 is equal to Q2 and equal to, both of them have the same value. And what is the value? 4 times 10 raised to power minus 8. That is what is given to us. Now, you ask yourself, what is my R squared? That is exactly what we're looking for. But before then, they gave us force. And what is our force? You pen it down. In physics, always bring out all your parameters. What is our force? The force given to us is 9 times 10 raised to power minus 3 Newton. From here, from the equation, from this particular equation, F equal to K, Q1, Q2, all over R squared. I can now generate my R squared as R squared, making it the subject of the formula, will have K, Q1, Q2, all over force. From that point, you can now move on to say that an r squared is equal to, you put in the value of q, your value of k, and your value of f. The value of k is 8.987 times 10 raised to power 9, bracket close. The value of your q1 is given as 4 times 10 raised to power minus 8. The value of your q2 is 4 times 10 raised to power minus 8, bracket close. Then everything there divided by f, which is 9 times 10 raised to power minus 3. So from here, you can generate your answer. Let's use the next board to conclude. So from there, we can say that r squared is equal to, r squared equal to, if you run all the calculations we did on the first one, you will get 143.792. 0.792 times 10 raised to power minus 7 divided by the force, which is 9 times 10 raised to power minus 3. Now that means that r squared is equal to, running the calculation there, we will get 15.98 times 10 raised to power minus 4. That means if that is what we have, for me to find my r, I need to take the square root. So we have r equal to, taking the square root of both sides, we have square root of 15.98 times 10 raised to power minus 4, which will give you 0.04. That means the distance between the charges r is equal to 0.04. And that is our final answer, 0.04 meters. Now, first question was able to calculate the force of interaction. The second question was able to calculate the distance between them. Let's touch one more question so that you have a perfect understanding of how to do this calculation. Question number 3 says, the force between two small charged spheres having charges of 1 times 10 raised to the power minus 7 and 2 times 10 raised to the power minus 7 placed 20 cm apart in air is dash. The same process. This time around is still asking for charge. So what do we do? The same way. First thing we said, put your formula. So let's go to a solution board. The first thing we'll do is to state our formula, which says that F is equal to K Q1 Q2 all over R squared. That's our formula. You now bring your parameters one by one. It's just a process. Don't cram physics. It's just a process. State your formula, bring your parameters out, and then substitute them. So we have K equal to, what is the value of K given to you? You already know it. 8.987 times 10 raised to power 9. Any day, anytime. Now, what is the value of Q1 given to us? They gave us Q1 as 1 times 10 raised to power minus 7 in coulombs. Then they gave us Q2 as 2 times 10 raised to power minus 7 coulombs. Then R, what is the R given to us? R is equal to 20 in cm. So we generate it in meters. To generate that in meters, we have 20 divided by 100, which is equal to 0.2 meters. Now, from that point, we've already gotten what we wanted. So, placing our equation back, F equal to, what do we have from here? F equal to K, Q1, Q2, all over R squared is equal to 8.987 times 10 raised to power 9, bracket close. Then times Q1 is 1 times 10 raised to power minus 7, while Q2 is 2 times 10 raised to power minus 7. Everything there divided by R squared, which is 0.2 all squared. Now let's go to the next board. Now looking at the next board, we'll continue from where we stopped. We'll have it that F will be equal to, running that calculation up there, I would like you to do that too with your own calculator. We have 17.974 times 10 raised to power minus 5, all divided by 0.04. And when we do that, we'll get from our calculation that F equal to 4.49 times 10 raised to power minus 3. So at the end of the calculation, we'll realize that F is equal to 4.49 times 10 raised to power minus 3 Newton. Final answer. Now, my dear, this is the way to run your calculation any day, anytime. The calculation number 1 helped us to know how to calculate force. The second one helped us to know how to calculate the distance between the force. And this third one helped us to calculate the force. So I would like you to run more examples on your own to see how these calculations are being done. Lecture review. I'm sure you have learned Coulombs Law. Yes, I'm very sure you've learned Coulombs Law. Coulombs Law states that the force of interaction between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. That's number 1. Number 2, electrostatic force. I know you must have been comfortable with that now, but if you're not, electrostatic force, we said, is the force of interaction between 2 charges. By force of interaction, we mean force that can cause the charges to attract or to repel each other. And we move further to say that is a force field. It's not a contact force. That means it doesn't require contact for the influence to be felt. Now, calculation using Coulombs Law. We've run 3 examples for you, and I would like you to do more on your own. Remember, the supreme equation that will help you handle that is F equal to KQ1 Q2 all over R squared. If you are having any problem on any equation at all in this particular topic, feel free to relate it to me at the comments. Thank you for listening. Our next lecture will be the total revision of all we learned for the week, starting from charges to properties of charges, to production of charges, to how bodies are being charged, to solid matters classification, that is conductor, insulator, and semiconductors. All that bonded in one lecture so that you will be able to catch up the places you're losing. Thank you and have a lovely time. Now, if you have any problem at all regarding this lecture or the ones we've done before, feel free to drop that at the comment section. But for now, have a lovely time and don't fail to click the subscribe button. Thank you.